Hello students, in our previous class we learned about coordinate of a point and how we can represent it on the xy plane. In this class we will learn how we can represent a polynomial graphically. That means the graphical representation of a polynomial. Okay, and then we will learn what do you mean by graph of a polynomial. Okay, so in this class we choose these four polynomials and for these individual polynomials we will draw their graphs. Okay, so before drawing their graphs, first of all we have to find a solution table. That means a table where we can write some solutions of these polynomials. Okay, so let us study problem number 1. Solution 1. This is a linear polynomial. So first of all, we have to let y equals to f of x equals to 2x minus 5. So therefore, y becomes equal with 2x minus 5. Now we have to find solution table of this equation, and after letting, that means when we let y is equals to f of x equals to 2x minus 5, then we get a linear equation with two variables. So now we will find the solution table of this linear equation with two variables. Now we have to put some values of x, and corresponding those values of x we have to find what are the values of y becomes. Okay, and here always we have to remember one thing. That thing is that always we have to choose the integral value of x. Okay, now if we put x equals to 0, then this will give y equals to 2 into 0 minus 5. That is 0 minus 5 is equals to minus 5. So when x equals to 0, then y becomes minus 5. When x is equals to 1, then y is equals to 2 into 1 minus 5, that is 2 minus 5 equals to minus 3. When we put x equals to minus 1, then y is equals to 2 into minus 1 minus 5, that is minus 2 minus 5 equals to minus 7. So here we find these three pairs of solution of this equation y equals to 2x minus 5. So now the solution points becomes x comma y is equals to 0 comma minus 5, 1 comma minus 3, minus 1 comma minus 7. Now we will plot these solution points on this xy plane. First point is 0 comma minus 5. abscissa is 0, and then minus 5. Minus 5 means ordinate is negative. When ordinate is negative, then we have to go below x axis. 1, 2, 3, 4, 5. This is 0, comma minus 5. Then 1, comma minus 3. Abscissa is positive. When abscissa is positive, we have to go on the right hand side of y axis. 1, then minus 3. Ordinate is positive. We have to go below x axis. 1, 2, 3. This point is 1, comma minus 3. Then minus 1, comma minus 7. Abscissa is negative. That is why we have to go on the left hand side of y axis. Minus 1 and ordinate is minus 7. It is also negative. So we have to go below x axis. Minus 1, 1, 1, 2, 3, 4, 5, 6, 7. So these are the 3 solution points which we plot on this xy plane. Now, if we join these points, then we will get a straight line. This straight line represents the graph of this polynomial f of x equals to 2x minus 5. So, after joining the points, we get a straight line. Which represents the graph of the equation y equals to 2x minus 5. So, after plotting the solution points may be 3 or more. When we join those solution points by a straight line, by a line segment, that line segment may be a straight line segment or a curved line segment or any other kind of segments. Then we may call that line as the graph. Okay. So here, after joining these points by a line segment, we get a straight line segment. That is why the graph of a linear polynomial always represents a straight line. So, the graph of a linear polynomial always represents a straight line. Okay. So, this is the way by which we can draw the graph of a linear polynomial. And after drawing their graph, we observe that that graph is a straight line. That means the graph of a linear polynomial is always a straight line. Okay. Now we will draw the graph of this polynomial 2, that is f of x equals to x square minus 2x minus 8. Same as previous, we let y equals to f of x equals to x square minus 2x minus 8. So therefore, we get y equals to x square minus 2x minus 8. So therefore, solution table. X, y. If we put x equals to 0, then this will give y equals to 0 square minus 2 into 0 minus 8, that is minus 8. So when x is 0, then y is minus 8. Now if we put 1, then y is equals to 1 square minus 2 into 1 minus 8. That is 1 minus 2 minus 8, that is minus 9. Now if we put x equals to minus 1, then y equals to minus 1 whole square minus 2 into minus 1 minus 8. That is 1 plus 2 minus 8. That is minus 5. In case of this quadratic polynomial, if we consider more values as a solution point, then we will get a clear graph. Okay, that is why we will take the maximum number of solution points. Okay, when x equals to 2, then y is equals to minus 2 whole square minus 2 into minus 2 minus 8. That is 4 plus 4 minus 8, that is 0. So when x equals to 2, then y equals to 0. So when x equals to minus 2, then y equals to, oh sorry, this will be minus 2 and this will be plus 2. So when x equals to minus 2, we get y equals to minus 2 whole square minus 2 into minus 2 minus 8, and this will give 4 plus 4 minus 8, that is 0. Okay. Now if we put x equals to plus 2, then this will give y equals to 2 square minus 2 into 2 minus 8. That is 4 minus 4 minus 8. This will give minus 8. So when x equals to 2, then y is equals to minus 8. Four plus 4 minus 8, that is okay. Now if we put x equals to minus 3, then y equals to minus 3 whole square minus 2 into minus 3 minus 8. That is 9 plus 6 minus 8. This will give 15 minus 8, that is 7. So when x equals to minus 3, y equals to 7. So So when y equals to 3, then when x equals to 3, then y equals to 3 square minus 2 into 3 minus 8. That is 9 minus 6 minus 8. This will give minus 14 minus 5. When x is 0, then y is minus 8. When x is 1, then y is 1 minus 2 minus 9. Then x is minus 1, then so the solution points are x comma y equals to 0 comma minus 8, 1 comma minus 9, minus 1 comma minus 5, minus 2 comma 0, 2 comma minus 8, 3 comma 7 minus 3 comma 7, 3 comma okay. So these are the solution points. We find more points to get a clear graphical representation of this quadratic polynomial. Okay, so let us plot these points on this xy plane. First of all, 0 comma minus 8. This is 0, negative means below x, ordinate is negative means below x axis. 1, 2, 3, 4, 5, 6, 7, 8. 1 comma minus 9. 1. Abscissa is positive, right hand side of y axis 1 minus 9. Ordinate is negative. That means we have to move on the below x axis. Minus 1 comma minus 5. 1, 2, 3, 4. Minus 1 comma minus 5. Plus 1. 1 when x is 1. Minus 1 comma minus 5. 1, 2, 3, 4. Minus 2 comma 0. 2 comma minus 8. 1, 2, 3, 4. Minus 3 comma 7. 3 comma minus 5. So these are the points which we plot on this xy plane. For our more clear graphical representation, now we choose another one or two values of these solution points. When x is 4, then y is equals to 4 square minus 2 into 4 minus 8. This will give 16 minus 8 minus 8, that is 0. So when x equals to 4, then y equals to 0. Now, if we join these points by line segments, and here the line segment is a curved line segment. If we choose another point, now if x equals to 5, then y is equals to 25 minus 10 minus 8, that is 7. 1, 2, 3, 4, 5, 6, 7. This is the clear view of the graphical representation of this quadratic polynomial f of x equals to x square minus 2x minus 8. Okay. So this graphical representation, or we can say this graph, is known as a special kind of graph. This graph is known as parabola. So after plotting the above points on the xy plane, we get a special kind of graph which is known as parabola. Opened at positive y-axis. Thus, the graph of a quadratic polynomial represents parabola. Okay, so this kind of graphical representation, that is, which may be opened at positive y-axis or may be opened at negative y-axis, okay, is known as parabola. So thus we can conclude that the graphical representation or the graph of a quadratic polynomial is always a parabola. Okay. So in this graph, the lowest point is minus 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. Minus 1, 9. Sorry, 1, minus 9. 1, minus 9 is the lowest point. Lowest point of the graph is 1, minus 9. Okay. So this point has a special significance. After learning the graphical representation of this third polynomial, we will learn what is the significance of this lowest point. Okay. Now in polynomial 3, same, we let y equals to f of x equals to this polynomial, and this is the solution table, and the solution points becomes 0, 3, minus 1, 4, 1, 0, 2, minus 5, minus 2, 3, 3, minus 12, minus 3, 0, 4, minus 21, and minus 4, minus 5. Okay, let us plot these points on the xy plane. 0, 3, 0, 3, ordinate is positive. Minus 1, 4, minus 1, 4. One comma 0, 1, 0. 2, minus 5, 2, minus 5, 1, 2, 3, 4, 5. Minus 2, 3. Three, minus 12, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Minus 3, 0. 4, minus 21. 4, minus 21. -4 comma -5. 1 2 3 1 2 3. So these are the positions of this point on xy plane. Now if we join these points by line segments, for more clearation, we take another point. Take x equals to -5. So when x equals to -5, then y equals to 3 minus 2 into -5 minus of -5 whole square. This will give 3 plus 10 minus 25, that is -12. So when x equals to -5, y is equals to -12. 1 2 3 4 5. 1 2 3 4 5 6 7 9 11. So this represents the graph of this quadratic polynomial. This graph is also known as parabola, and this parabola and the previous parabola. That means the graph of this polynomial 2 are different. What is the difference? The difference is that this is the downward parabola and the previous graph, that is the graph of the polynomial 2, is an upward parabola. Okay, so this is the highest point. The coordinate of this point is -1 comma 4. So highest point of the graph is -1 comma 4. Okay, so after plotting all the points on the xy plane, so after plotting all the points on the xy plane and joining them by line segments, we get a special kind of graph known as parabola. Here the parabola is opened at negative y-axis. Okay, so the graph of polynomial 3 is a downward parabola. That means that parabola is opened at negative y-axis, and the graph of polynomial 2 is also a parabola which is opened at positive y-axis, that is which is known as an upward parabola. Okay, and for these two different graphs, for the polynomial 2, its lowest point is 1 comma minus 9, and for this polynomial 3, its highest point is minus 1 comma 4. So these 2 points, that means this lowest point and this highest point, has some special significance. Now we will learn what are the speciality of these two extreme points. Okay. So graphs of so graphs of the polynomials 2 and 3 represents parabola which are upward, which are respectively upward and downward parabolas. Okay, so after seeing the equation of the quadratic polynomial, or after observing, that means at a first look, how we can understand the the graph of that polynomial will be a upward parabola or a downward parabola. Okay, so the general form of the second sorry general form of the quadratic polynomial is f of x equals to ax square plus bx plus c, where a not equals to 0. Already we know this is the general form of a quadratic polynomial. When a greater than 0, then the parabola is opened at positive y-axis. Okay. So for this general equation, for this general polynomial, the general form of the quadratic polynomial, when a is greater than 0, then the parabola is opened at positive y-axis. In problem number 2, here the coefficient of x square is 1, which is greater than 0. That is why this parabola is opened at positive y-axis. Already we find its graphical representation, and we see that its graphical representation, that is this parabola is opened at positive y-axis. Okay. In problem number 2, f of x equals to x square minus 2x minus 8, a equals to 1, coefficient of x square greater than 0, and we see that its graphical representation is an upward parabola. Okay. When a less than 0, then the parabola is opened at negative y-axis. In problem number 3, f of x equals to 3 minus 2x minus x square, a equals to minus 1, that is coefficient of x square less than 0, and we see its graphical representation is a downward parabola. Okay. So from this general form of quadratic polynomial, how we can understand the parabola will be an upward parabola or downward parabola. Okay. So when a is greater than 0, then the parabola will be an upward parabola, which is similar with problem number 2. And when a is less than 0, then the parabola will be a downward parabola, which is similar with problem number 3. Okay. Now we will learn what is the significance of this lowest point, or how we can find this lowest point for this general form, that is ax square plus bx plus c. where if we want to find the lowest point or the highest point of this parabola, then we have to study the general equation of the parabola. Okay, and then after comparing the general equation, the general form of quadratic polynomial with that parabola, we can find the lowest or the highest point of a quadratic polynomial, or we can say parabola. General equation of a parabola is that means general equation of upward or downward parabola is x minus alpha whole square equals to 4a into y minus beta, where alpha comma beta is known as vertex of the parabola or highest or lowest point of the parabola. So this is the general equation of upward or downward parabola, that is x minus alpha whole square equals to 4a into y minus beta, where alpha comma beta is known as vertex of this parabola, and this vertex, this point alpha comma beta, also known as highest or lowest point of the parabola. Okay, now we have to compare the general equation of the parabola. Sorry, now we have to compare the general form of the quadratic polynomial. So let y equals to f of x equals to ax square plus bx plus c, where a not equals to 0. So this is, we know this is the general form of a quadratic polynomial, and after letting this y, we get an equation of a quadratic form. So therefore, we have ax square plus bx plus c equals to y. Multiplying both sides by 1 by a, we get this. So this will give x square plus bx by a plus c by a equals to y by a. Now we can form an identity. Now, if we convert this y equals to ax square plus bx plus c in this form, x minus alpha whole square equals to 4 into y minus beta, then we get x plus b by 2a whole square is equals to 1 by a in whole into y minus of minus capital D by 4a, where D is equals to b square minus 4ac. So, comparing 1 and 2, we get alpha comma beta is equals to minus of b by 2a comma minus of capital D by 4a, where capital D is equals to b square minus 4ac. Okay. So this point alpha comma beta, which becomes equal with minus b by 2a comma minus of D by 4a. For more clarification, we can write this as okay. So this is equals to alpha and this is equals to beta. Thus we get alpha comma beta is equals to minus b by 2a comma minus capital D by 4a, where D is equals to b square minus 4ac. So this point alpha comma beta will give the highest or lowest point. So now if we choose this equation or polynomial 2, f of x equals to x square minus 2x minus 8, then a is equals to 1, b equals to minus 2, c equals to minus 8. So alpha comma beta is equals to minus b by 2a comma minus capital D by 4a. This will give minus of minus 2 by 2 into 1 comma D means b square minus 4ac. So b square minus 4ac means b square minus 4 into a into minus a by 4a. 2 by 2 comma 4, so 36 minus of 36 by 4. This will give 1 comma minus. Now if we compare this polynomial 2 with the general form, that is f of x equals to ax square plus bx plus c, then we have a equals to 1, b equals to minus 2, c equals to minus 8. So now alpha comma beta, that is the lowest or the highest point of the parabola, alpha comma beta is equals to minus b by 2a comma minus capital D by 4a, where D is equals to b square minus 4ac. So alpha comma beta is equals to this, and after calculating we get this is alpha comma beta is equals to 1 comma minus 9, which is equal with the lowest point of this parabola, which we find after drawing the graph of this parabola. Okay. So similarly, we can also find the highest point of this parabola 3. So this is the way by which we can find the lowest or the highest point of a quadratic polynomial. and the quadratic and the graphical representation of a quadratic polynomial always represents a parabola, and that parabola will be an upward parabola that is opened at positive y-axis when a is greater than 0, and that parabola will be a downward parabola that is which is opened at negative y-axis when a is lesser than 0. Okay. There is one more thing, students, that is there will be a plus minus. When we have to consider this plus when there is a upward parabola, and we have to consider this minus when the parabola is the downward parabola. Okay, so we have to clearly understand these signs, that means positive and negative. So for this upward parabola there will be x minus alpha whole square equals to 4a into y minus beta, and for this downward parabola the equation will be x minus alpha whole square equals to minus 4a into y minus beta. Now we will check how this highest point of this parabola comes with the help of this vertex. So alpha comma beta is equals to minus b by 2a comma minus d by 4a. If we compare this parabola or the polynomial f of x equals to 3 minus 2x minus x square with this general form ax square f of x equals to x square plus bx plus c, then we have a equals to minus 1 coefficient of x square, b equals to minus 2 and c equals to 3. Then putting this here we get minus of minus 2 by 2 into minus 1 comma negative of d. D means b square minus 4ac. b square means minus 2 whole square, that is 4 minus 4 into a into c, that is 4ac is equals to 4 into minus 1 into 3. This is minus 12. So this becomes plus 12 by 4a, that means 4 into minus 1. This 2 by minus 2 comma minus 16 by minus 4. This is minus 1 comma 4. Yes, so this value alpha comma beta is similar or equal with minus 1 comma 4, which is the highest point of this downward parabola. Okay, so thus our graphical representation of these three polynomials, that means 1, 2, 3 is completed. In our next class we will learn the graphical representation of this polynomial 4, and then how we can find the number of roots of a polynomial by its graphical representations. Okay.